Today we are starting a new concept which is recursion and backtracking. Let's just give me a heads up that whoever know about recursion. If you guys know recursion, then I'll just wind up recursion in very few minutes and start backtracking. Otherwise, if you guys need more detailing related to recursion, I'll go in detail related to recursion. Because without recursion, you can't understand backtracking. And backtracking is a very complex, and believe me when I say it, it's very confusing. Dry running questions related to backtracking is very difficult, guys. So if you know the concept of recursion, then only you can do backtracking. Function calling itself again. Yeah, Ananya, that's very good. You know the definition of the recursion, but here I'm asking about the main fundamental things, like how recursion works. If I give questions related to recursion, can you solve it within few seconds itself? Like, do you know the concept clearly? Have you guys solved few questions related to recursion? If yes, then we will start backtracking. Or else we will start from recursion itself, from scratch, from basics. So fundamental thing is when a function calls itself, when function inside function, we are calling this function again. When a function call itself, then that's called recursion. In recursion, it contains two parts. One part is when a function call itself. Another part is base condition. What is base condition? Base condition is assume if a function calls itself, at that time it will go here, function call, it will go here, function call, it will go here, function call. So what's the end? When to end? It goes into infinite loop, right? So how to end this loop? To end this loop, we need a condition which is called a base condition. Each and every recursion function should compulsorily have a base condition. Without writing a base condition, we can't write recursive functions. Okay. So few examples, real world examples where recursive functions are used is, one famous example is factorial. What do you mean by factorial? If you want a factorial of 4, then what you will do, okay, I'll write it here. If you want a factorial of 4, what you will do? You'll write 4 into 3 into 2 into 1. Again, if you want a factorial of 5, what you will do? You will write 5 into, and you have to write till 1, right? So you'll write 5 into 4 into 3 into 1. So this is 5 factorial. So what you can guys do is, if this whole thing is equals to 4 factorial, at that time, you can bring this 4 factorial here, right? Okay. You can bring this 4 factorial itself here. So basically, if you want to write 6 factorial, at that time, how we will write 6, the number 6, and 5 factorial. Again, if you want to write 7 factorial, we will write 7 into 6 factorial. So basically, what function we are calling? If we need x factorial, what we will write x into x minus 1 factorial. I think I messed up. Guys, is this correct? 5 into 4 factorial, yes, x into x. Yes, it's correct. I can see many people are leaving, joining. Is there anything related to my issue? Guys, am I audible? Is my video clear?
Yes, your voice on video screen is visible, no? But issue is from my side. Actually, there is some network issue.
Okay.
Yeah, due to raining also.
Okay. I saw many people leaving, joining the meeting. It was unusual. That's why I asked it. That's it. This today I have continuously on my laptop from afternoon. I guess that's why I thought it's from my side. It's okay, guys. Leave. So factorial, you guys already know the condition is x. If we need to find the factorial of x, then we have to multiply x into x minus 1 factorial. So let me just start the backtracking. Then I will ask a few questions. Our next concept is backtracking. So what is backtracking? Backtracking is basically recursion plus undo. That's it. So one more, if you guys don't know related to backtracking, right? I'll give a best test example from where you can get the answer related to backtracking. Okay. Oh shit. Wait. You guys have seen something like this, right? Where in some cases, you will be having a mouse here, which is a cute mouse, and here you will be having a cheese. So mouse want to get this cheese. So what it will do? We have to iterate. Let's just consider this is also okay. Now what we will do? We will go like this. We will go like this, like this. We'll go here, but it's a dead end. So what we'll do? We'll go come back and we'll go here. Again, it's a dead end. At that time, what we'll do? We'll come back over here. Next, we'll go here. We'll go here. Again, dead end. What we'll go? We'll come back here. We'll come here. We'll go here. Again, dead end. So we'll go down. We can go. Oh, now we got the path. So I guess everyone have played this game, right? Guys, interaction. Everyone played this game, right? So knowingly or unknowingly, you are using the concept of backtracking there. How backtracking is, what you are doing, you are choosing a path. Okay, let me just write the steps. What you will do, you will start from first. Okay, you will start from a point. Next, what you will do, you will choose. You will choose. There are three options. Right? 1, 2, 3. What you will do, you will choose. First, you will choose this option. Okay, you will choose. You will start. When you start, you are having few options. You will choose first option. Next, what you will do, after choosing the first option, you will move in that direction. When you choose the upper option, you move in that direction. Later, what you will do, when you move, you got an end. When you reach end, and you didn't reach your answer, but you reached the end. At that time, what you will do, you will come back. Go back. Go back to the, you came here, you came here, you came here. You will go back to the place where you had one more option. Again, you will go here again. You will go back. You will, again, what you will do, you will go back to the place where you had another option. You will go here. Come here, you go here. This is the steps you follow. So what you will do, you will do this again and again and again and again until and unless you get your final answer. You get your finished line. So this concept is only a description of backtracking. So basically in backtracking also we follow the same steps. So let me give you another example. I'll give you like unofficial example first, then I will give you an official example. The time is nearly 10 o'clock, right? So let's talk about food only now. Consider this as a pizza. Okay, in this pizza, you are allowed to have 2 toppings. Okay, consider cheese as 1 topping and pineapple as 1 topping. Okay, what is the condition? At most, you can add 2 toppings. So in your pizza, what you will do is, first you will eat your pizza without toppings, right? No toppings. Next, what you will do is, you will add cheese. Next, with cheese, you will also add pineapple. Next, if you then also you didn't like, what you will do, you will have only pineapple. Right? These are the 4 options which you can do. Similarly, backtracking is also same. So you will start with an empty array. Next, what you will do, you are having 2 options, C and P. So you will start with an empty array. Next, what you will do, you will add first element C. Next, what you will do, you will add another element P. Next, what you will do, you will remove P. Then it's again C. So you already have C. Next, what you will do, you will finish C. Okay, you end all the possible connections starting from C. Then what you will do, you will raise your index and you will start from P. When you raise your index and start from P, again, I will explain again. Okay. You are having C and P. C is cheese, P is pineapple. Okay, you are having 2 options. So what you will do is, currently you start from empty index. Empty array. You don't have anything, no toppings. You haven't added anything. Okay. Now what you will do is, first you will add cheese. Okay, you will take this index. Using cheese, you will see all the combinations. Okay. Here also what you did is, you first choose first option here. Using this first option, you went all the possible options later. From going up, you can go to here, you can go to here. You had 2 options, right? So using this, you will see all the possible options. After seeing all the possible options also, if you didn't reach your finish line, what you will do, you will come back to this original place. That's why later what you will do, you will eradicate, you will delete this option and you will start a new option. So basically, this is also similar to that line. So here what are you doing? You are choosing the first index now. By choosing the first index, you will see all the options. What is the options? The first option is cheese itself, only cheese. So C is your answer. Next, with cheese you can add pineapples. So with cheese you can add pineapple. Are there any more options with the cheese? No, right? At that time, what you do? At that time, this case is over. Using cheese, it's done. Next, what you do? You will eradicate cheese and go to pineapple. At that time, what you need to do? You will delete when you are here, right? So you will delete pineapple. At that time, it's a little bit confusing for you guys. When you are at C itself, right? So you added an element. Then what you did? If there was another element, you will get it in second example. Okay. So next what you will do is you will delete P. When we delete P, we will get again C. So we already have this C, right? So we will not write in our answer. Next what we will do? We have done all the combination with C. We will eradicate C and have start with P. Freshly starts with P. So using P, are there any possible options? We have already eradicated C. There are no possible options further. So at that, these are the four conditions. If, for example, let's see few technical example. We are having 1, 2, 3. This is array, integer array, having elements 1, 2, 3. Now what we have to do? We have to write all the subsets of it. The first subset would be empty array. Obviously, empty array is a part set. Empty array is subset of all the arrays. Next, what we'll do? We will start from 1. Okay, 1 is our index. Next, what we'll do? We will add one element. So 2. Next, what we will do? We will add another element also. So 1, 2, 3. Here we are getting answers. Okay, in this box we are getting our answers. 1, 2, 3. Next, what we will do? We will remove 3. Okay, we will remove 3. Next option is 1, 2. When we write 1, 2, we already have that, right? So in our solution, we can't have duplicate one. So 1 and 2, this combination is already over. Next, what we will do? We will remove 2. When we remove 2, what we have? We have only 1. Again, this 1 we already have in our answer here. At that time, what we will do? We will remove 2, we will add 3. So from here, we took this path, then this path. Then what we did? After completing all the elements from this path, what we will do? We will eradicate this path, this element, and we will go here. So 1 and 3. Again, are there more elements to add? There are no more elements. There are no more elements in front of 3. At that time, what we have to do? We have to eliminate 3 also. When we eliminate 3, what will be remaining? Again, only 1 will be remaining. If we remove 3, only 1 will be remaining. That is already present in 1. So we have written all the possible conditions starting with 1. Next, what we have to do? We have to eliminate 1 itself and start from 2. So when we start from 2, first statement is 2. First one is 2. Next, what we will do? We can add 3. 2, 3. Then, is there any more elements? No. At that time, what we will do? We will delete an element. When we delete an element, again, when we delete 3, we will end up with 2. 2 we already have here, so we will not get it again. So at that time, are there any more possible ways starting from 2? No. So we will eliminate this also. We will start from 3. So 3. Again, we don't have more elements to add. That's why what we will do? We will remove element. When we remove element, we will get an empty set. Empty set is already present. So 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 subsets of this array.